Jakarta Persistence API, Hibernate, Lab 1. 1. Lesson Objective. In this lesson, we build a minimal application that uses the JPA with Hibernate to map a simple domain object to a relational table and perform basic data persistence within a transaction. The goal is to understand how the persistence unit wires the database and entity mappings, how the persistence context manages entities, and how transactions ensure consistent writes. 2. Big picture. JPA is the specification, and Hibernate is the provider that implements it. A persistence unit describes the database connection, the JPA provider, and the list of managed entity classes. The application bootstraps a factory for creating persistence contexts and then uses a persistence context to manage entities and coordinate with the database. Data modifications occur within a transaction so that changes are atomic and consistent. 3. Project structure. There are 3 key parts to focus on. First, the entity class represents the table structure and column mappings for the domain model. Second, the persistence configuration defines the provider, connection properties, SQL logging, and schema strategy. Third, the launcher runs the application, opens a persistence context, performs writes within a transaction, and cleans up resources. 4. Persistence unit configuration. The persistence unit sets the provider to Hibernate and specifies the fully qualified name of the entity class it manages. It provides the database driver, URL, user, and password. The dialect matches the target database to generate appropriate SQL. SQL logging and formatting are enabled to make interactions visible during development. The schema strategy is set to create, which recreates the schema on each run, useful for a clean sandbox while learning. 5. Database options. The configuration targets a local relational database with credentials and a specific dialect. There is also an alternative set of properties commonly used for an in-memory database that can be enabled if you prefer a self-contained environment for experimentation. Whichever you choose, all related properties must be kept consistent so that the provider can connect and generate SQL correctly. 6. Entity mapping. The domain model represents a company with an identifier, a required name, and an optional address. The entity is mapped to a specific table and columns. In this lesson, the identifier is assigned by the application before persisting rather than being generated by the database. This keeps the focus on the persistence flow without introducing identifier generation strategies. 7. Bootstrapping JPA. At startup, logging is configured so we can see what the provider is doing. The application creates a factory from the named persistence unit and obtains a persistence context from it. The persistence context is the unit that tracks entity states and coordinates with the database session under the hood. The factory is designed to be created once and kept for the application lifetime, whereas the context is scoped for a unit of work. 8. Transaction and persistence flow. A transaction is started before any changes are made. Instances of the entity are created, their fields are set, and they are made managed by the persistence context. When the transaction is committed, changes are flushed and translated into SQL statements. If anything goes wrong during the unit of work, the transaction should be rolled back to maintain consistency. 9. What you will see in logs. Because SQL logging is enabled and formatted, you will see the provider creating the schema based on the entity mapping and issuing statements for inserts. This visibility is essential while learning, as it lets you correlate entity state changes with actual database operations and confirm that the configuration and mappings are correct. 10. Database effects. With the schema set to create, the table for the entity is recreated each run. This means previously inserted data is cleared, making the sequence of operations predictable during the lesson. After committing, the new rows appear in the table with the identifiers you assigned. Use a database client to verify that the records are present and the schema matches the mapping. 11. Common pitfalls and fixes. A mismatch between the persistence unit name in configuration and the name used to bootstrap the application will prevent startup. Incorrect driver, URL, user, or password will block database connectivity. A wrong dialect can cause SQL mismatches. Forgetting to start a transaction will usually lead to errors on write. Recreating the schema each run is fine for learning but will wipe data. Switch to a different strategy when you need persistence across runs. Since identifiers are assigned manually here, reusing the same identifier will cause primary key conflicts. 12. Key takeaways and next steps. You now have a working mental model of how JPA with Hibernate is configured and bootstrapped, how entities are mapped, and how transactions wrap data changes. Next steps could include reading entities back, exploring queries and the query language, switching identifier strategies to generated values, experimenting with different schema strategies, and trying an in-memory database to iterate faster while practicing.